Hello everyone. In this video, let's discuss how to insert the element in the beginning of the linked list. First, let's create a head node and we'll initialize the value as null. If the value of head is equal to null, it states that the linked list is empty. Now we are going to insert our first element in the linked list. Let's create a node. After creating a node, we have to initialize a value for that particular node. We know that node consists of two parts, data and address part. First, let's initialize the data part. We'll initialize the data value as 10. Now we have to store the address part of the node. So for this, we have to take the value which is stored in head that has to be stored in the new node address part. The reason why we are taking the value which is stored in the head in the sense, we are going to insert the element in the beginning of the linked list. If we are going to insert the element in the beginning of the linked list, the already existing first node becomes the second node and the newly created node becomes the first node. Head should always point to the first node address. That is why we'll take the value which is stored in the head and we'll store it in the new node's address part. Now after this, we have to store the new node address in head. The new node address is 2000, that will be stored in head. The link will be created. Let's take one more example and let's get to know how to insert the element in the beginning, because the linked list was empty and we have inserted the first element. When we are inserting the first element in the linked list, we will not be having the clear picture how it has been inserted in the beginning. Now we have an element in the linked list. I am going to insert a new node in the beginning of the linked list. Okay, let's create a new node. After creating a new node, we have to initialize the value for the data part. Okay, after initializing the value of data part, we have to initialize the address part. So here we have to take the value which is stored in head. The reason why we are taking the value which is stored in head in the sense, so far this is the first node of the linked list. When I insert this node becomes the first node of the linked list. So we have to know what is the address of the first node. The reason to know the address of the first node is nothing but when I insert a new node, this node becomes the second node and second node address has to be stored in the address part of the first node. Okay, and we know that head will contain the first node address. So the already existing first node address will be stored in head. So I'll take the value which is stored in head, I'll store it in the address part of the new node. After storing it, the new node address will be taken and that will be stored in the head. The reason why we are taking the new node address and stored in head, because head should point to the first node address. When I insert this element in the beginning, this node becomes a first node and this becomes a second node. So we'll take the new node address and we'll store it in the head. Now this becomes a first node and the already existing first node becomes the second node. We have inserted the element in the beginning of the linked list. Now let's go for the implementation of this program. Let's start with preprocessor directive. Hash include IO stream using namespace std. We have to define a node, right? Node can be represented with the help of a structure. And we know that node consists of two parts, data and address of the next node. And we know that structure has to be terminated by a semicolon. The execution always starts with the main function. Okay, let's create a head pointer. Struct node star head is equal to null. We have taken a head pointer and initialize the value as null. When I go for the memory, so a pointer called head has been created and memory has been allocated and we are initializing the value as null. Now let's get the size of the linked list. Int n. Cn n. Let's take a for loop and we'll iterate the loop for n number of times, because we are going to insert the element in the beginning of the linked list for n number of times. Okay, here we are going to get the element which we are going to insert the element in the beginning of the linked list. So I'll declare a variable called element cin element. Okay, whatever the value which you are going to get from the user, we have to insert in the beginning of the linked list. For that, I'm going to call a function insert in the beginning. Here I'm going to pass two arguments. One is nothing but address of the head variable, and the next one is nothing but the element which I'm going to insert. So these two arguments I'm going to pass to the function. Let's define the function now. This function is not going to return me anything, so I'll give void insert in the beginning. Here I'm going to pass two arguments, struct node star head ref in element. Here how many arguments I have passed? Two arguments. And here I have passed address of head pointer variable. So to dereference it, I need to have two pointers. So here I have declared two variables. One is head ref, which is a double pointer, and another one is an element to insert in the beginning of the linked list. First, let's insert the element called 10. Okay. Here I have passed the address of a head pointer variable. What is the address of head pointer variable? 1000. 1000 has been passed, and that has been stored in a double pointer variable called head ref. So here 1000 will be there, and the element which I have passed is 10. Okay, let's allocate the memory for these two variables. Fine. Here first we have to create a new node. Struct node star new node. So we have to allocate a memory for this particular pointer variable, right? New node. Okay, memory has been allocated. The memory location is 1012. After this, we have to create a node. A node consists of two parts. So here, by using malloc function, let me allocate memory for this particular node. Size of struct node. So we have allocated a memory for a node with the help of a malloc function. Let me create a node. So node consists of two parts, data, and the next one is next. Now the base address of this particular structure will be stored in new node, because after allocating memory for this node, the base address has to be stored in new node. So the base address of the newly created node is 2000. That has to be stored in new node. Okay, done. Next, we have to initialize value for the new node. So new node of data is equal to element. So here what will I store? I'll store 10, because the element value is 10. So that has to be stored in new node address is 2000. In 2000, the data part is this. I'll store the value as 10. And new node of next is equal to star head. Okay, here star head ref. Here what am I going to do? Head ref is a pointer variable, which is a double pointer variable, and I have given single star head ref, which means I have to dereference only once. So in head ref I have a memory location called 1000. I'll dereference once. When I go to the memory location 1000, I have a value called null. So I'll take this null, and that will be stored in new node of next. So new node address is 2000. In 2000, data part is this, address part, next part is this. Here I'll store the value called null. After this, what will I do? I'll take the new node's address, and that will be stored in head ref. Head ref is equal to new node. What is the new node address? So the new node address is 2000. So the base address of this new node is 2000. That has to be taken, and that has to be stored in star head ref. Star head ref. So head ref is a double pointer, and when I go for a star head ref, we have to dereference once. So I'll go to the memory location 1000. On the memory location 1000, I'll store the new node address. The new node address is 2000. So I'll store the 2000 here. Now let's see whether the linked list has been created or not, which means I have to insert the element in the beginning of the linked list. Head contains the address of the first node 2000. I'll go to the memory location 2000, data part, and the next node is null, which states the end of the linked list. So I have inserted the element in the beginning of the linked list. Let's try to insert one more time. So after this, what happened? I'll go to the function where I have called. The value of I will be incremented. Then I'll insert an element called 20. Let me try to insert an element called 20. Again, I'll be calling a function. I'll pass address of get and the element. So address of get will be passed. The element this time 20 will be passed. So I'll go to this particular place. Head ref I have address of head. Address of head is 1000. 1000 will be passed, and for element 20 will be passed. Now I have to create a new node. So by using malloc function, I'm going to create a new node. So let me create a new node. Okay, I have created a new node, and this will be my data part, and this will be my next part. Fine. Now I have to initialize a value for the new node. New node of data equal to element. So what is the value I have passed for the element? 20. So 20 will be stored in new node of next. And before this, the base address of this new node has to be stored in this particular pointer variable. So 3000 will be stored here. Okay, because I have to create a new node. After creating a new node, the base address has to be stored in new node. So the newly created node is this, and the base address of this will be stored in this particular place. Next, new node of data equal to element. So the element value is 20, that has to be stored in new node of data part. New node of next equal to star href. Href is a pointer variable, which is a double pointer variable. I have to dereference once. So dereferencing in the sense, I'll take the memory location 1000, I'll go to the memory location 1000. What value I have? 2000. I'll take this 2000, that will be stored in new node of next. So 2000 will store in new node of next. Fine. After this, new node address has to be taken, that has to be stored in star href. So href 1000, I'll go to memory location 1000. So here what do I need to store? I need to store the new node address. What is the new node address? 3000. So 3000 has to be taken, and that has to be stored in this particular memory location. Now let's traverse the linked list. Okay, head contains the first node address. Head contains the first node address. So 3000 is the first node address. Okay, so this is the first node. Data part is 20. I'll go to next node address, which is 2000. I'll go to 2000. So this is the second node, data part, and next is null. That's all. We are in the end of the linked list. So earlier this was the first node. Now this is the first node. So we have inserted the element in the beginning of the linked list. Let's quickly print and check. I'm going to call a function called print list. I'll be passing a head pointer variable. Let me define this function, void print list struct node star head. I'll take a temporary variable to traverse the linked list, while temp not equal to null. What will I do? I'll print temp of data. Already we have seen the traversal part, so quickly I'll take it through the code. I'll give a space between the nodes. That's all. Finally, I'll give return 0 for the main function. So let me give the size of the linked list here. I'll give it as 4. I'll give 4 elements, 10, 20, 30 and 40. Let me run the code. Print list was not declared. Okay, I have an error here. Okay, I have missed underscore because the function call, it has print underscore list. The function definition, I have missed this underscore. That's why it was showing an error. Let me run once again. Okay, I've got the answer. I've got 40, 30, 20, 10. Actually, you may think it is a reversal, but actually this is not the reversal. Here I have inserted the element in the beginning of the linked list. Initially my linked list will be empty. I have inserted 10. Then after 10 I have to insert 20. So 20 has to be inserted in the beginning. So 20 will be inserted in the beginning. Then 30 has to be inserted in the beginning. Then 30 will be inserted in the beginning. Then 40 will be inserted in the beginning. Then 40 will be inserted. Now when it traverses the linked list, it will print 40, 30, 20 and 10. So this is the correct answer. That's all.